An object in JavaScript can have a single link to some other object. The effect of this link is that when we access a property of an object, if the object doesn't have a property of that name, JavaScript will look for a property of that name in the object linked by the first object. So say we have three objects, an object orange with three properties, A, B, and C, a red object with two properties, A and D, and a green object with two properties, B and E. If the green object links to the red object and the red object links to the orange object, then via the red object we can access B and C of the orange object, and via the green object we can access C of the orange object and A and D of the red object. The way to think of this behavior is that accessing a property triggers a search for that name, a search that follows the chain of links until a property of that name is found. So notice that accessing the property A via the green object returns A of the red object, not the orange, because the search starting from green goes to the red object first. So let's see how this link behavior plays out in code. For now, we'll elide over how to create these links. Just assume that object ACK here links to the object bar, and the object bar links to the object foo. Well then, the expression foo.c equals bar.c equals ack.c will return true because they actually all refer to the same property, the property C of the object foo. Bar and ack have no property C of their own, so accessing a property C on those objects follows the chain up to the foo object where a property of that name is found. Now, if we then assign to bar.c a value 8, this creates a property C in the object bar. In fact, assignment to a property always affects that object itself. The link search behavior only applies when we access properties, not when we assign to them. Now that bar has its own property C, the expression ack.c will return the value of that new property in bar, but foo.c will still return the value of its own property C. It turns out that the basic types in JavaScript, like strings, numbers, and arrays, can act in some ways like objects. A string, for instance, has a property named length, whose value is the number of characters in that string. For instance, this string hello has a property length with the value 5 because the string has 5 characters. Be clear though that strings aren't really objects. You cannot assign to a string's property length or assign the string additional properties. Strings do, however, all have a link to another object, a special object which contains methods useful for strings. One such method is charat, which returns the character of the string at a specified index. When I invoke foo.charat1, the method returns a string of one character, the character at index 1 of the string hello, which is the second character E. Again, the indexes here start from 0, such that 0 is the first character in the string. In the last line, when I invoke charat on the string avast with an argument 3, the method returns the character S, the fourth character of the string avast. Understand what's going on in these calls. Though the strings themselves have no property charat, the strings link to an object which does, and because we invoke charat as a property via the strings get passed to the special parameter this in charat. Also understand that what this arrangement accomplishes is really nothing we couldn't do without methods, properties, or object links. We could instead just have a regular function charat in the global namespace to which we would pass both a string and an index. This arrangement, however, is a bit more convenient and neatly keeps the global namespace uncluttered. To create a link from one object to another involves the new operator. The new operator is a unary operator which takes as its operand a call to a function. What the new operator does is pass a newly created object to that function's special parameter this, and what the function then returns, regardless of any return statement, is that newly created object. So here, when we invoke this function tom with the new operator, a newly created object is passed to the special parameter this. The object then gets assigned two properties, foo and bar, and the newly created object is returned and assigned to the variable Jane. Now, it turns out that every function value has a property called prototype, an object which starts out empty when the function is created. When we invoke a function with the new operator, the newly created object gets linked to this prototype object. So here, if we create a property ack in the prototype object of tom, we can then access ack via the Jane object because the Jane object links to the prototype object of tom. Again, the JavaScript equivalent of what Pigeon calls a list, JavaScript calls an array. An array is created with a literal syntax of square brackets enclosing a list of values separated by commas. To access, modify, or add items, we use square brackets much like we do to access, modify, or add properties of objects, except inside the brackets, we put a numeric index rather than a string. So here, for example, we assign to foo an empty array, and then assign to bar an array of 3 items, the number 4, a string hello, and the number 33. We then assign to ACK the item of bar at index 2, in other words, the third item of bar, the value 33. Lastly, we assign to index 3 of bar a string orange. Because bar previously had no item at index 3, this effectively expands the size of the array by 1. Unlike Pigeon, we don't have to explicitly expand an array with an append operation. We can instead simply assign to any index, whether the index is currently in range of the array's current size or not. In fact, the dirty secret of JavaScript's arrays is that they are really just objects in disguise. The item of an array at, say, index 2 is really just a property with the name numeral 2. So if we write these numeric indexes as strings, the code actually functions just the same. The only way arrays really differ from objects is that arrays have a special property called length, which is meant to report the number of items in the array. In truth, though, what the length property actually reports is the number which is 1 higher than the greatest numeric property name. So here, foo.length returns 0 and bar.length returns 3 as we should expect. However, if we then assign to index 15 of bar.length returns 16, even though we've only added one more item. All the indexes from 4 to 14, such as index 8, remain undefined. So understand that there are scenarios in which the length property will actually misreport the number of items in an array. Inside a function, JavaScript always includes a special local variable called arguments. The arguments variable holds an array of all the arguments passed to the function. Whereas in Pigeon, a function must always be called with the same number of arguments as the function has parameters, in JavaScript a function can always be called with any number of arguments. When a function is called with fewer arguments than the function has parameters, the excess parameters get the value undefined. When a function is called with more arguments than the function has parameters, the only way to access these excess arguments in the function is via the arguments array. Using the arguments array, we can write a function which sums together all the arguments passed to the function, no matter how many arguments are given. We'll call this function sum, and notice it has no parameters. In the function, we use a variable sum to keep tally of the value we're going to return, and we use a counter variable I to step through each item of the arguments array in a loop. I starts out at 0 and gets incremented by 1 at the end of each iteration, and the condition tests whether I is less than arguments.length. So the loop will iterate with I incrementing from 0 up to but 1 less than the length of the arguments array. In each iteration, we take the item of the arguments array at index I and add it to our sum. Once the loop completes, we return sum. So if we call the sum function with the arguments 2, 2, and 3, we get 7, sum with arguments 5 and 7 returns 12, and sum with no arguments returns 0. Because when the arguments array is empty, the loop is never entered, and so the initial value of sum, 0, is returned.